Assalamualaikum and hi, my name is Muhammad Abasi Faizal, TA1088, and I will explain about the introduction of our group project, which is about the hybrid subtractive additive manufacturing process for high value added metal component. So this paper propose a method to improve the manufacturing process by combining additive manufacturing, which is about the building part layer by layer, and also the subtractive manufacturing, which is about the removing material to shape the part. So the method focus on making better decision during the manufacturing process by using simulation and also the planning. It consider factor like inspecting the part, measuring any deviation in the shape and size, and also determining the best way to combine additive and also the subtractive process. So by using this method, the researcher were able to dynamically switch between adding material using laser and also to remove the material using milling based on the inspection and also during the manufacturing process. So this is to ensure that the part were growing consistently and to meet the required specification. Okay, that's it from me. Thank you.
In this literature review, the additive manufacturing processes involved are deposition on damaged area in pyritizing, on-counter accuracy, and high deposition rates. The subtractive manufacturing processes involved are finishing of the part in pyritizing, low surface roughness, and also the inspection applied are identifying the damage of component parts by updating the 3D model after the damage removal process. The overall framework from picture above for hybrid manufacturing, emphasizing the optimization of life-to-value product, and it divided into three stages. The first stage focuses on a hybrid process planning alternative for manufacturing operations. There are some users inputs such as metal parts, constraint requirements, and new part to be repaired. From this stage 1, it includes two main activities, which are operation sequencing and operation planning. The second step is modifying the original process parameter using simulation and modeling of additive and subtractive processes. By applying the process simulation, parameter optimization and validation techniques using experimental data, the unwanted defects can be avoided. Process reliability and part quality also can be enhanced. In third stage, the decision maker is given the opportunity to conduct an overall evaluation of a manufacturing alternatives, which will result in a life to value performance score for each of them.
Greeting, my name is Abdul Rahim bin Muhammad TA1089. I'm going to talk about the methodology of the hybrid subtractive additive manufacturing process. First is the defining the objective. We need to know what we are going to do, what product we are going to make, taking into consideration the functional need, the geometric complexity, and material and surface finish. So the second one is the CAD and designing modeling. To build a digital representation of the part or produce, use the computer-aided design (CAD) software. Design the item taking into consideration both the subtractive and the additive manufacturing processes. Third is the material selection. Material selection determine the best material for the project based on the desired characteristic and functional specification of the part. Take into consideration of how well the material will work together when combined, as well as how they work with additive and subtractive manufacturing technique. Fourth one is the subtractive manufacturing. It is the beginning of the process of the production process. It utilizes the traditional machining techniques such as milling, turning, drilling, boring, etc. To create critical features and achieve the intentional shape of the part. Next is the inspection. And validation. Inspection and validation inspect the partially machined part to make sure it complies with the specific tolerance standard. Inspection check for part shape such using and measurement equipment such as caliper, CMM, or 3D scanner. So next one is the additive manufacturing. The additive manufacturing transfer the partially machined product to the additive manufacturing system. Select the appropriate additive manufacturing techniques such as SLM, selective laser melting, the FDM, diffuse deposition modeling based on the requirement of the project. Additive manufacture the complexity features, the internal structure, and customized element of the part. So next one is the post-processing. Post-processing, once the additive manufacturing stage is complete, carry out the post-processing operation as necessary. The process includes removing the support system, smoothing the surface finish or heat treatment, and etc. So next is the inspection and quality control. Inspection and quality control double check whether the final hybrid manufacturing part complies with the standards. Do dimension analysis, surface quality inspection, functional testing to verify the part performance and functionality. So next is the iterative refinement. Iterative refinement adjusts the design, production parameter or process for as necessary if the inspection reveals any problem. Repeat the step to get the desired result. The last one is the documentation and finalization. Documentation finalize the document of the manufacturing process, which includes all the design file, the manufacturing specification, and inspection finding. All these documents will be used as future references in future production. So what are the advantages and disadvantages of hybrid as additive manufacturing process? The advantages are the design flexibility for producing complex and customized parts, improve efficiency and reduce lead time, high precision and surface finish on critical area. The disadvantages are it increases complexity in the production flow, higher capital investment in equipment and software, longer cycle time compared to traditional method. But the advantages is better than the disadvantages, because the hybrid subtractive additive manufacturing process can produce a product that cannot be produced by traditional method.
Hi, my name is Muhammad Azizul Akmal and I will continue about result and discussion. For the result, 3 of alternative generated, which are alternative 2, alternative 5 and alternative 7, been demonstrate the effectiveness of the method were further analyzed and evaluated. Each alternative used different sequence and set of process parameter for the operation. For the AM operation, 2 set of process parameter been applied. However, the subtractive operation, 3 and 2 set of parameter are used respectively. The process parameter set are shown in table 1 and 2 as a result of the second stage of the process planning framework, and table 3 display their combination and process step for each possibility. Surface roughness of the top and side surface of the blade, total process time, tool life goals for the 10mm side milling tool and 2mm face milling tool, and material waste are all measured as the KPI. The resulting priorities are determined using pairwise comparison as defined in the AHP technique with a consistency ratio of 5%. The KPI priorities and raw value per alternative are shown in table 4. The raw KPI value are then normalized. The normalized computation for each KPI range between 0 for the poorest choice and 1 for the best alternative. The normalized value multiplied by the priority yield a score. The total score are computed for each alternative and alternatives are ranked accordingly. Table 5 show the outcome of this method. For the discussion, based on the result, alternative 2 method is the preferred one among the 3 alternative process plan. This method allows for more effective use of the AM process by keeping stable material development and so needing less post-processing with milling, which reduce total process time and material waste. In addition, alternative 5 and alternative 7 are similar in terms of overall performance, while having differing specific process stage, parameters and consequent performance in each KPI. This demonstrates that more than one choice can exhibit comparison performance, making the process of selecting one relatively simple. As such, the proposed method is a useful tool in assisting the user in having a clear overview of the potential options, allowing the user to shift to another alternative process plan if new constraints arise, such as a change in priority, machines availability, and increase in the cost of a particular resource, and etc.
This study proposed a novel process planning method to improve hybrid process change, design, and maximum product life to value ratio. The technique efficiently creates hybrid process plan option using simulation and testing data. Seen it evaluates alternative depending on user need. It allows multiple criterion evaluation. Applying the concept to gas turbine blade replacement show that the alternative hybrid process chain can achieve the same component quality while varying in time and tool wear. This technique capture and rank various possibilities, showing their benefit and cons. Data can be used for production planning, inventory management, and also hybrid manufacturing design adjustment. There are some recommendations that have been offered for further research based on the finding of the paper. First, the development described in the paper should be combined into a single software tool to make it easier to create effective mid-process change. This tool should make the planning part of a process easier and let you quickly evaluate and compare different options. Second, it is important to assess how well hybrid process chain work with certain material, parts, and also application. Also, industry standard should be considered when figuring out if and how well this process chain will work. And the last recommendation are more study is needed to figure out how hybrid process chain affect the structural integrity of repair part, especially for structure that are necessary to ensure safety. It is very important to make sure that the fit part meet the right standard and do not put the user in danger. By addressing this suggestion, future study can improve the use of hybrid process planning and help make the industrial process more efficient and effective.
End of this video, we have prepared some common question regarding our topic. So I think that's all from us. Group 1, thank you.